In this video, I'll be working through the question you see on the screen here. It's from the 2024 Leaving Cert exam Honours Level Paper 1. If you're looking for a different question from that paper, you should be able to find a playlist in the description below. I'll be doing all this on a whiteboard, hopefully so it's similar to what you're used to your teacher doing. But we're not in a classroom, we're on YouTube, so take advantage, pause, rewind, stop, rewatch, all those things you can do on YouTube. If you find this video useful or any of my videos, I would greatly appreciate a like, a subscribe, and what helps most is sharing it with a friend that's doing the Leaving Cert or one that's going to do it next year. In question 9, they give us a formula for the cap of a sphere. So we have a sphere here, and they give us a formula for the volume of this area on top. Imagine if you cut off the top of a sphere, and that's this formula they show here. And in part A, they ask us to find the volume of a cap if the radius of the sphere is equal, let's see, 13, and if the cap, the height here, is equal to 4. So really we're just filling these numbers in. Yeah, there's not much to it than that. 4 squared is 16. They want the answer to leave pi alone. So we'd get 16 over 3. In here we'd get 3 times 13, that's 39 minus 4. So what would that be? That would be 35. 35 times 16 is 560 divided by this 3 times pi. Leave your answer as that. Or yeah, I think it could be 186.66 repeating pi's. Either one's fine, but I'd leave it as a fraction, as a matter of course. Okay, on to part B. In part B they tell us the radius r is equal to 8 and y is equal to k. So k is equal to y, I guess. And they tell us quite obviously that y has to be bigger than 0 and less than 8. Because remember, if the radius is 8, k couldn't be any bigger than that, because it'd be a different formula if it cut at the bottom. And it can't be less than 0 and so on. And they want us to use, and they tell us the answer, volume, or C. C is equal to 36 pi y. And basically they want us to solve this, put it all together, and they tell us what the answer will look like. They want us to get the answer out of y over 3, want us to get a function out of this, 24 minus y is equal to 36. So this is part 1. And part 2, then we're just going to go ahead and solve that. So let's get to this first. We just fill in the numbers they give us. We go up here, instead of c, first of all, we get 36 pi y equals pi. Instead of k, we're putting y in, so pi y squared. 3 is still 3. Instead of or, we're putting in 8, so that becomes 24 minus, instead of k, we get y. We're pretty much there. This is a very strangely easy question. The 2 pi's cancel. Y cancels with one of these y's. And we're just then, what do they want us to look like? Yeah, 36. Oh, 36 is where it's meant to be. 36. Y over 3. Yeah, that's fine. Actually, yeah, we're done. We're already done. I'm sorry. Like I said, a strangely easy question. Then for part 2, they just ask us to go ahead and solve this. Remember, it's one equation, one unknown. We go ahead and solve it. Let's just multiply it out and make it look like a quadratic. 3 by 3 multiply over here and y multiply in here. We get 24y minus y squared is equal 108. Rearrange all this so it looks more like quadratic. I always like to make the y squared as a plus. So y squared minus 24y and a plus 108 equals 0. Go ahead and solve this. It's actually not that clear that it factorizes. You could try factor things into it. 2 goes in 54 times, well, too far apart. 4 goes in 27 times, that looks good. 4 and 27 could make 23, can't make 24, that's close. 6 goes in, oh no, does it? Yeah, 6 goes in, let me just check my notes here. Yeah, 6 goes in 18 times, and 6 and 18, yeah, they do make 24. So 6 and 18 Two minuses would make a plus here, and minus and a minus would get to the 24 here. So we're left with the answers y is equal 18 and y is equal 6. Now be careful here, because they get you lots of clues why this isn't the answer. First clue was they flat out told you at the start of B that y has to be between 0 and 8. So if you give this as an answer, you're going to lose marks. But then also in part 2, they just asked you to find the height, not the heights. There's no S at the end of there. There's not a plural. So they told you there's only one answer. So we should be able to discount this guy here. And also remember, it's 8 radius. So 18 would be all the way down here. It wouldn't make sense. And that happens when squares come involved. Sometimes we get an answer that doesn't make sense. Discount it and give the only answer as y equals 6. Okay, on to part C. Part C, they give us a formula for the volume of a hemisphere. Phi x is equal to pi divided by 12 multiplied by x cubed. And that's when x is the diameter. Now, just so you're aware, we already knew the answer to a volume of a hemisphere. It's in your formula book. More to the point, it's just half a sphere. It's a sphere cut in half. But usually we have it in radius, so you should be able to figure this out on your own. Even this seems to be a theme in the last couple of questions. They're giving you a formula that you don't necessarily need. You should have been able to work this out on your own. So some exams, this might be its own question, like find in diameter instead of radius the volume of a hemisphere. Anyway, they've given it to us now, and they've simply asked us to find what x is when the volume is 3. So we just get, instead of v, we get 3 is equal to pi over 12x cubed. Rearrange all this, we'll get x cubed is equal to 36 divided by pi. Then x is equal to 36 divided by pi to the power of 1 over 3. That simply goes into a calculator, and to the nearest one decimal place is 2.3. Okay, then on to D for a much trickier question. The volume of a hemisphere is increasing at a constant rate. So think of it getting bigger and bigger at a constant rate per second. So let me write that before I go any further. The volume is increasing at a constant rate. Changing, D is the letter for change. We use D with respect to time. That's differentiation with respect to time. The volume rate of change with respect to time is equal to 450. That's basically what they've told us. This is a common question. You need to recognize that English linking up to something like that. And they want you to find the rate of change of the diameter. Again, let me write that. They want you to find dx dt, the rate of change of x, the rate of change. When we say rate of change, we're nearly always talking in time, but I think they explicitly say it with time anyway. And they want to find out this when x equals 20. We'll worry about that later, but you would write that like this, x equals 20, but not important if you missed that bit. And that's it. We have one more bit of information. They even tell it to us again. The volume is equal to this up here. So we want dx dt. We have dv dt. How do we get it? I'm just thinking how to explain this. Yeah, how I would usually just explain this is we want this. Let's write this down here. dx dt. But hopefully you should be seeing, I want v involved. I would like v involved. This is a very common question. It's the chain rule. We're going to change this guy to get v involved. We're just going to put dv here and here. You can think of this, although from my college days, I remember this isn't technically correct for more complicated maths, but in this simple maths we're doing, it does work. dv and dv cancel. I know it seems like they're dividing, but still, we can just think of them as cancelling. It works for this case. And we're left this equals this. So that's what we're going to do. Also, dx dv, that's going to be difficult to get, but this would be the same as we leave this guy alone, dv dt, and if we flip these upside down, that'd be multiplied by 1 over dv dx. This is easy to get because we have v in x. We can just straight away do this. This is dv dx is equal to 3x squared multiplied by that. So 3 pi over 12. The 3 came down multiplied and the x became x squared. So this is what we want. And we have dv dt 450. The question told us that. We just had to figure it out. And we divide that. Let's write this again one last time. dv dt. You often see it in a book like this actually. dv dx. So remember, we're just looking for dx dt. So let's go ahead and start putting it in. dx dt is equal to, and this is the one we'll use it from. dv dt is 450. Divided by dv dx is, where's that? That's down here. 3 pi, actually 3 and the 12 cancel. Leaves a 4 down there. So pi over 4 x squared. Let's see, the 4 divide by 4, so that 4 just comes all the way up here. So that is equal to 1800 over pi x squared. Then also remember that x is equal 20. That's what we're interested in here. So that's 1800 over 20 times 20 is 4 and 2 zeros, 400 pi, and that equals, that goes in 4.5 times divided by pi. And how do they want us to leave the answer? Oh, 1 decimal place. Okay, so must be here somewhere. Yeah, so if we put that into a calculator, well, 4.5 divided by 3.1, yeah, that looks about right to me. 1.4 when I rounded it off. Okay, in part E, they give us this formula here of S, where S is the curved area of a cone. They don't draw it, so we don't really need it. The curved area of a cone, and they just simply ask us to rearrange this where H is on its own. Rearrange this to write H in terms of S or in pi. So this is just a question that you'd see in your book, like when it gives a list of 20 ones. Take this formula, rearrange it. Take this formula, rearrange it. So hopefully you should be able to do this. Rearrange it so H is on its own. Let's first get rid of these two guys. We'll rewrite it as S divided by pi or is equal to the square root of r squared H squared. Next we need to get rid of this square root. So, sorry, yeah, did I say square root a minute ago? Anyway, we need to get rid of this square root. Square both sides. So I'll get S squared over here, pi squared, r squared is equal r squared plus H squared. Okay, next take r squared from both sides. We get S squared over pi squared, r squared minus r squared equals H squared. Last thing then, get square root of both sides. That's H is equal to, sorry, I say last thing, not quite, S squared over pi squared, r squared minus r squared. Okay, sorry, I probably blocked a bit of that there. That would be a answer, except they ask specifically for their answer to look like, it's right over here. They want their answer to look like S squared minus some constant A multiplied by r to the power of something all over, outside the square root now, B, some constant B multiplied by r. So we don't quite look like that, have some similarities. So what do we do? First thing I notice is they want a single denominator. That's very common when you're rearranging stuff. You want both these guys on the same bottom row. So let's jump over here. We get H is equal, sort of write this again. Yeah, let's just sort of write it again. S squared over pi squared r squared. So they want this guy over the same common bottom row. So, sorry, r squared here. So let's just add in pi squared r squared over pi squared r squared. So I haven't changed anything. I put a pi squared r on pi r squared on the top, pi r squared on the bottom. They cancel. This is the same as this. But look what I'm able to do now. I'm able to do s squared minus pi squared r to the power 4 all over pi squared r squared. And also this bottom row is just one constant thing and they're both squared. There's a square root, goes all the way over both of them. So next thing I can do is get the top row, s squared minus pi, I think this is the last thing actually. Bottom row, square root of the squares, they just cancel. We get pi or. This is now as they want the answer. Let's double check. They want s squared, square root of the top. Wait, yep. Minus, we have minus a constant. Pi squared is a constant. Don't be confused, there's no squared here. Pi squared is just a constant number, so it's valid. Or to the power of 4, or to the power of a constant number. 4 is a constant number. All over, no square root down here, just a constant. Pi, again, is a constant, times just or. This is it. That's full answer to part E. Like a difficult rearranging, but nothing too strange or uncommon. The real trick was, were you able to change this into this? A bit of practice on that one. And again, any maths book will have about 20 of these questions. Somewhere in the early chapters, actually, just at the back of the early chapters. 20 of these questions. Do them all. You'll be fine. Okay, thanks for watching that video. If you do have any problems or see any problems I made, let me know in the comments. Thanks for watching, and I'll see you next time.